everyone, and welcome. This is the latest tech talk on IEEE 802 networking standards, and today we're focusing on industrial Ethernet. My name is Jennifer McLean. I'm a Senior Product Manager with IEEE Educational Activities, and I will be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen, there are engagement tools, which are resizable and movable, so you can move them around to make the most of your dashboard space. If you have questions for today's panelists, you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen. We will answer as many questions as time allows. If you click the green resources icon, also at the bottom of your screen, you'll find more information about IEEE 802 standards and past and future virtual events. Finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEELearn. So let's get started. Ethernet is expanding into the industrial application space. When industrial automation began to apply Ethernet in the 1990s, it began with a traditional information technology model for one-on-one information purposes, such as programming devices from a laptop and extending to some real-time control. The discussion today will explore, among other topics, how the benefits of connecting the devices by standard protocols, such as Ethernet and IP, continue to grow, not only by enabling Industry 4.0 and 5.0 with widespread wired and wireless solutions, but new adaptations in standards for Ethernet, such as single-pair Ethernet and associated protocols for time-sensitive networking and wireless applications. Our panelists today are Paul Nikolich and George Zimmerman. Paul Nikolich is chair of IEEE 802 Landman Standards Committee, overseeing 75 active technical standards and the 50 concurrent projects for wired and wireless networking applications. George Zimmerman is president of CME Consulting. He recently chaired the IEEE 802.3CG 10 megabit single pair Ethernet task force, standardizing single-pair Ethernet transmission and powering for industrial and building automation, as well as intrasystem and automotive applications. And so now I'll turn it over to Paul to get us started.
Thank you, Jennifer, and welcome to everyone that's joining us. I just want to make a note that during webinars like this, the views that are being represented by George and myself specifically are our personal views and not the views of IEEE. So just to set the tone at a top level, the mission of IEEE 802 Landman Standards is the development of high-quality, market-relevant networking standards. And we've been very successful given that the number of devices deployed annually exceeds 1 billion per year based on 802 standards. Today's focus is on an important emerging market for Ethernet and 802 standards, industrial Ethernet. And we're fortunate to have George Zimmerman with us today, an expert on the topic and a leader of related 802 standards activities in the industrial networking application space. So let me start off with a two-part question, George. A, why is the industry moving towards a standardized approach? And B, how do 802.3 standards enable this movement?
Well, thanks, Paul. If you look at the factory floor, a modern factory floor today, it's networked, and it's networked with this wide variety of special purpose, specially designed network that have been put in place over the years, and it's a variety of protocols and a variety of technologies to actually tie all the machines together, the sensors, the actuators, and monitoring equipment. At the other end of the network, you have what we've all become familiar with in the offices with an Ethernet or Wi-Fi, and actually almost all offices today have an 802-based network, where technologies that have been provided by 802 are used to tie together computers, telephones, information databases, and ultimately in the factory, those are tied into that network of specialized equipment at the other end. Well, how does that happen? It happens because it happens with the help of this layer you see in the middle here on this slide of a whole lot of translators and gateways and the things that connect the office network that we're all used to the factory floor network that's all very, very specialized. That's a lot of complication. Now, standardized Ethernet sort of walked into the factory floor where it could, but today you have this sort of web of complexity between the back office control and the factory that if you went to a standardized approach, you'd be able to clear out.
Excellent, George. So I've heard some people talk about that as Industry 4.0, I think is what it's being labeled as. What are some of the important operational characteristics of this industrial network?
Well, and that's kind of at the root of it, is that when you think about your office network, most of the things you do in your office network aren't real time. You don't care if somebody gets their email 1 second from now or 2 seconds from now. I mean, you probably care if they don't get it for a number of minutes or hours, but the difference of a second or 2 seconds doesn't really matter. But if you're controlling, say, for example, a robot arm on a factory floor, that 1 second is the difference between the robot arm reaching to put something on the hood of a car going by on a conveyor, or the arm going straight through the window of the car. So time matters on the factory floor. Time sensitivity is a very, very important characteristic. Another important characteristic is the availability of power. When you have relatively low power devices, small devices, sensors, little actuators, obviously not the big robot arm or the arc welder, those require a lot of power, but things that really are just there to communicate information or act on some simple information. Having to run extra wires for the power and the data is kind of a big deal. So providing power and data together is another important characteristic on the factory floor. And the third thing that's different on the factory floor than in the office are the distances involved. A factory floor could be, for example, with some of the guys I've worked with, an oil refinery. And there's an oil refinery not far from where I live in Torrance, California. And it's probably a better part of a mile long. And if you actually had to trace out a path through there that a wire might run, it might be longer. Some of these things are out to 1 kilometer long, as opposed to when you talk about an office environment, a floor of a building is pretty well covered by a tenth of that distance of cabling at most, and in most cases much less. So you got time sensitivity, power and data together, and reach are very, very important characteristics of an industrial environment. There are other ones, such as some of the electrical characteristics of being in an environment might have explosive materials, but those are the big ones. And they're a little different than office networks.
All right. Very good. Thanks, George. Yeah, clearly, those requirements are very different than the capabilities of Ethernet, existing Ethernet specifications or legacy Ethernet specifications. So it's interesting, given that the industry already has proprietary networking equipment deployed, why would they want to go to a standardized approach?
Well, that one's kind of simple. When you go into this proprietary network, you've got proprietary needs already, but if they are specialized, you're going to have to find people who are trained in those particular specializations, right? You got to go find somebody who's trained in a Modbus or BACnet or a particular field bus application that you're using, as well as somebody who knows about what you want to do on your factory. So combining those skills makes for a very rare kind of person, and that actually ripples all the way back through the value chain. It ripples back to the people who make the equipment you're going to use on the factory floor, people who make the devices that you're going to use in there. When you go to a standardized approach, and particularly something as widely standardized as 802 technologies, your skills base, the people you can draw from, are much broader. You can take an engineering student out of college, or actually they don't even have to be an engineering student. Many people I know deal with 802 networks. They're not engineers at all. As a user, my kids can deal with 802 networks, and they didn't follow their dad into engineering. But they, the existence of standardized technologies makes the skill set much more readily attainable. And ultimately, that is going to go and feed everywhere on the value chain, which is going to increase competition. It's going to increase innovation. It's going to increase the variety of things that are available. So you have stuff that's available right for your task, and the people to use them. And in the end, it's just going to lower the cost of ownership all around.
Excellent points. And that's one of the reasons we have such a robust level of participation in 802, is that the industry recognizes those benefits and they invest a significant amount of resources in developing the standards. So talk a little more about the cost benefits of a standardized approach, George.
So to begin with, if the people are more available, you're not only going to be able to get somebody who knows more things to help you do your job better, but you're going to be able to get them at the right cost. It's not going to be the extremely rare expert who you have to hire, who everybody needs for exactly that particular purpose. But beyond the people, standardized approaches mean, and one of the things we do in 802.3 is we look at a broad market potential. Actually, 802 in general, we look at a broad market potential. We look for multiple vendors and multiple customers. So I can take the same common Ethernet interface, I can use it in a variety of applications, and because now people are making more of that same interface, there are more suppliers, there's more competition, there's more volume, and that's going to lower the cost as well. And finally, that common interoperability and the existence of well-trained people who know how to deal with that interoperable equipment is going to pay cost benefits all around, because in the end, it's about not having something that ends up being completely special purpose built for your application.
Great points, George. And I think, as you mentioned, the fact that we're able to encourage competition and have lots of common components that are available, and the performance of the networks are at the quality necessary to meet the needs of the applications, are all factors in the success of standardized approaches. Specifically, let's talk about one of the projects that you led, the 802.3 CG signal pair Ethernet. How did the industry bring the requirements into 802.3 working group and encourage the start of the standardization activity of the single pair Ethernet?
So ultimately, Paul, and you know this for our audience, it all starts with individuals. The individuals come in and they say, look, we have this, here's our problem, and we think 802 might be able to help. And one of the most interesting questions, I guess, all the time is, how do I become a member? Well, you don't. You just show up. 802 meetings are open. And so what happened is some folks from the process control industry came in and they showed up at 802, and they explained their problem, and they explained their needs, and they talked about the needs for this kilometer-based solution, that they didn't really need high data rates, that they really needed to be able to provide power as well. And they already knew about the 802.1 work that would be compatible with it. That's the time-sensitive networking, so they want to be able to run that in as well. When they showed up, there were some folks there from the automotive industry, and they said, when it comes to your short-range links, we actually have some similar problems. We need a low-speed networking link, and we actually today we use these shared media, these bus connections, like you see in the bottom left there, where all the transceivers are actually sitting on the same wire, which something Ethernet hasn't really spent a lot of time on for the last 20 years, but it's back at its roots. And not only those automotive folks say that, but there were a bunch of semiconductor designers in the room, and they looked at it and said, we've done some similar things. We're interested in that. We could work on that. And together with folks who were from the networking space, who've been, primarily make office networking equipment, but also make for industrial networking applications, they got together and they said, we can make a project here where we can make Ethernet that fits your industrial needs, works for the automotive needs, and has some other applications, say in building automation. And that's where 802.3CG came from. That group of people sort of got together and they started pitching ideas, and their ideas, one person's ideas sort of got grabbed by another person, and the group began to put that together as a new standard. And this is ultimately how standards evolve. Somebody brings their problems into the standards group, and others will see opportunity and similarities to their own problems and abilities.
Good points, George. And I would just like everyone to know that 802 meets on a very regular basis. When we do meet face-to-face, which has been consistently for the last 40 years until 2020, we meet face-to-face for week-long sessions 6 times a year, where you have hundreds of engineers and business people gathering to develop these requirements. And we meet virtually via web conferencing many times a week. So it's easy to engage. So please consider it. George, I'm going to ask a 2-part question here. Are the 802 technologies being deployed on the factory floor today? And what's in the pipeline? What's coming that is new and we haven't heard about yet? So
I'll start with the first part there, and that is, are 802 technologies being deployed on the factory floor today? Yes, and more yes. They've been the office technologies, the Wi-Fi, the 4-pair Ethernet, even optical networking, have found their way out into the factory floor. They just haven't necessarily found their way all the way out in there. And as we've developed things like 802.3CG, that's going to fill out more of what's in the on the factory floor. The stuff I talked about with 802.3CG, we expect to see rolling out over the next year or two. Those are devices that are currently in the sort of design and test point of view. I'd be surprised if you walked onto a factory floor today and saw those. But you know, a year or two from now, you will be seeing those. As far as what's coming new in the pipeline, one of the most interesting things that happened in this is I always think about 802.3cg as a return of Ethernet back to its roots. We started to look at 10 megabit and shared media, which haven't been looked at for over 20 years. And we looked at them through new technology and the fact that, you know, today, the whole world is looking to be networked. 20 years ago, a network was, you know, what a bunch of guys did who were interested in computers, not what somebody did who was interested in, you know, a fire alarm system or building a factory. And for example, we had people come to us from the elevator industry. They said, well, I need this adapted a little more for elevators or for the lighting industry, and saying I want to have sensors. I'm pointing up at the lights in my room here. I want to have sensors that tie those together. And so we have a new project, 802.3DA, which has just been started and is still looking for a lot of input, which is looking at extending the capabilities of the 10 megabit multi-drop work that went on in 802.3cg, so that we can fit better into some of these building automation and other what we call operational technology networks.
Excellent, George. Thank you very much. So I'd like to open the floor up for questions now and see what, as the audience, what questions they may have. Jennifer, can you help us out?
Sure. So we have, the first question is, can you comment on the leading applications that will deploy in the industrial Ethernet in the future?
I'm not entirely sure I understand the nature of the question, but if I go out, in terms of applications, if I go out, say, into, I mentioned an oil refinery or a chemical processing plant, and I go through that plant, I find a wide variety of flow sensors, of actuators, valves. It's sort of basic mechanical stuff. That's all going to get networked. It all is proprietary network today, but that's a primary place for industrial Ethernet to happen.
George, let me say, I think one of the opportunities here is using Ethernet to connect all these sensors and actuators and connecting them to the back-end infrastructure opens up the potential for the automated control over these, you know, many or very large, complicated factory scenarios that previously you had to have people doing the control. Now potentially you can have machines doing the control and doing it in a more efficient way.
Well, you do that, and you do have machines doing it to some extent today with the proprietary networks. But by going in and building this big Ethernet, this big Ethernet network, you not only have that control, but you have the monitoring and you have the integration back into the back-end processing. So they can not only control it, they can predict faults, for example, before they happen. And the kind of things I'm talking about here are, for example, if you're in an oil refinery, you are mixing chemicals at some pipe that's, you know, half a kilometer away from you, and you've got a valve there. There's a flow meter associated with that. There may be a sensor there associated with what the actual mixture ratio is, and there may be an actuator there to control the actual flow. All of those can end up being networked together.
Okay, thanks. Jennifer, any other questions?
Yeah, we have quite a few. Is industrial Ethernet being used in combination with traditional Ethernet for high-speed networking needs?
Oh, George, I would say yes.
Yeah, so yes, and if you go all the way back to that and I'll flip back to it, that slide that I started with, that Ethernet gap in industrial networking, all that stuff at the top is traditional high-speed Ethernet, and in fact, today it goes back to a high-speed data center. So it becomes this big seamless Ethernet stack everywhere from that high speed down through the Ethernet switches into and across that, what used to be that sort of nest of translators, into these lower speed Ethernets that go out onto the factory floor.
So, George, there's an interesting question I see here. Is 802.3CG half duplex? A nice techie question for you.
Oh yeah, somebody's been doing their homework. 802.3CG has within it two physical layer devices. There's the long reach there's the long reach that actually I'll go to, yeah, this is probably the right one, that goes out over the kilometer, but there's also a short reach, what's called 10-base T1S, which fills needs in cars, it fills needs in factory pods, and that short reach PHY, as we call it, has a half duplex mode. And the half duplex mode is primarily there to allow it to work on shared media networks, what we call multi-drop in 802.3CG speak. So yeah, but not always.
Okay, here's another good one. Regarding Ethernet in OT networks such as the automotive industry, can you speak a little bit about how it is protected from possible attacks?
So protection from attacks is usually at a higher layer than I deal with. I'm a physical layer guy. I deal with devices that talk on wires. Protection of attacks is usually something that happens at what we engineers will call layer 2 or above. It's a logical thing where you're looking at the bit streams. So in 802 networks in your offices today, for example, there are technologies such as MACsec. There are gateways. There's encryption, which is all layered on top of the 802 networks. That can be layered on top of the same 802 network in an automobile or otherwise. And then, of course, in the car, there's generally the usual access control barriers as well. But I have to say I'm not really an expert on the security in the car.
Okay, Jennifer, do you have any other questions that you think would be interesting?
There's one more. Are you able to incorporate industrial Ethernet and a 5G network?
Ooh, what's 5G? That's a whole nother tech talk.
Yeah. And how, I mean, so if I think of a 5G network as a network, and I say a 5G network, I think most people would agree, enables IP connectivity for devices, enables devices to connect through internet protocol. Those same internet protocol packets can be routed out over that industrial Ethernet link. I think you could do a whole nother tech talk on 5G networks, and even on 5G networks in the factory, which I've seen some presentations on. I think it's a little more than we've gone here today, but suffice it to say, the two are quite synergistic.
Okay, very good. George, Jennifer's prompting me. We are out of time. I want to thank you sincerely for giving us your time today and everybody that's participated, as well as to Jennifer and the IEEE staff. So Jennifer, you take it away, wrap it up.
Yeah, thank you both so very much. We really appreciate it. And thanks to everybody who joined us today. As noted earlier, the on-demand link for the event will be emailed to all registrants in approximately 2 hours. And keep an eye out for our next virtual TED Talk, Tech Talk. It'll be on Wi-Fi sensing on November 4th at 9 a.m. Eastern Time. And before you leave, please complete our feedback survey via the tool at the bottom of your screen. And we thank you again and have a great day.
Take care, everybody. Thanks for joining us.